All right, ladies and gentlemen. So today we're going to just see some application. So law of sines and its application. So we're going to solve this function, like not function, sorry, this trig problem right here, triangle problem, and then which picture matches your answer. Now notice, just before we even start comparing, here we have a degree, an angle that is more than 90 degrees. And then on this one, all angles are smaller than 90 degrees. So that's how we're going to know which one's which. So let's solve. Now look at that. We have a pair of angle side, A and A. So we can use the law of sines right off the bat. So we're going to use A over sine A equals, let's solve for B, B over sine B. So this is going to be 4.5 over, let me use a different pen real quick so you can see it easily. So this would be 4.5 over sine 58 degrees. Remember, this has to be in degree mode. And then this is 5 over sine B. Now, I've already showed you how to solve for this on a calculator, so just plug and chug, solve for everything. So now we know that B equals 70.437 degrees. So 70.437 degrees. And then letter C, you just do the old switcheroo, subtract everything from everybody. So C equals 180 minus 58 minus 70.437 degrees. So subtract all that good stuff on the calculator and you end up with 51.563 degrees. So now we have almost everything. Now we just need to figure out little c. Okay, little c is the only one we need. So we use the law of sines again. So I'm going to use, A over sine B. That looks like a 3. Sorry about that. Equals C over sine C. So plug and chug, 4.5 over, and I messed up this, is supposed to be sine A. So 4.5 over sine 58 equals little c over sine 51.563 degrees. You solve this however you want, okay? I recommend you just figure out what these are, the values of these, and then just solve for C using your calculator, like using basic algebra in your calculator. So after you do all that, C equals 4.156 meters. And now notice how all of these 58, 70, 51 are all smaller than 90 degrees. Well, this has an angle that's bigger than 90 degrees, so this is bad. This one does not work. So our answer is this one, okay, the one on the right. All right, so now let's go ahead and talk about some possible scenarios. All right, so here are the scenarios, all right, and let me explain what they each mean. So when A is an acute angle, okay, when, as you can see right here, A is an acute angle. Here we're given triangles. Consider ABC given that AB and A such that the height is B sine A, okay, where H is the altitude of triangle C. Notice when A is an acute angle and little a is smaller than H, no triangle can exist because A, if you can see right here, I'll bolden this, A can't reach to make the triangle. So therefore, no triangle can exist, okay? Because A is smaller than the height. It can't even, for example, if I were to draw this and then let me move it over, it can't, if I keep it the same size, it can't reach the bottom to form any kind of triangle, okay? Now, if A equals H, well, the height and the A are exactly the same height, which form a right triangle, okay? So if the side length A is the same as the height, then you have a right triangle. If A is bigger than B, which means this length is longer than this length, well, then you have exactly one triangle to work with. Now, and this was a little bit confusing, if H is smaller than A is smaller than B, then you have two possible triangles, as you can see here. If that's your H, okay, and this is your B, well, A can either be here or here, forming two separate triangles, okay? The big one or the little one that's in between. Okay, so two possible triangles. You can see here with the yellow and the blue. All right. Now, if B is an obtuse angle, which means it's bigger, well, if A is smaller than B, then no angle exists. Sorry, no triangle exists because it can't reach all the way to form a triangle. So therefore, no triangle. If A is greater than B, then it can form at least one triangle because now it can go all the way over here and there's your triangle. Okay, so those things you just have to keep in mind. Now you guys are in charge of all the questions because all you got to do is set them up. So I'm going to help you set up the first one, and then you are in charge of using the law of sines and cosines to figure everything out. Okay, so an Earth orbiting satellite is passing between the Oak Ridge Laboratory in Tennessee and the Langley Research Center in Virginia, which are 46 miles apart. So we have a satellite. Now you have no idea how to draw a satellite, so I'm just going to draw it like this. There you go, satellite in the sky. And now there's two locations on the ground, this building and this building, and it's hovering in between them. So we can start seeing the triangle. Let me draw those straight. We can start seeing the triangle that is formed between these. Okay, again, not looking for perfection. And now we know that the two centers, or the laboratory and the center, are 446 miles apart. Okay, let's call this, I'll do it in a different color, angle C, and this is little c. Okay, we're going to call this angle A. This is little a, and then angle B, and this is little b. Okay, just label it however you want. If the angles of elevation to the satellite from Oak, oh, and by the way, we have to label this. So let's label this one as Oak, and this one is Langley. So now, if the angle of elevation to the satellite from the Oak Ridge and Langley facilities are 58 and 52, and let's work respectively. So this is 58 and 52 degrees. So Oak came first, 58 came first, Oak gets 58. How far is the satellite from each station? Well, we have A, B, C, A, B, C. So we have A, which is just 58. We have B, which is 52. You guys can figure out C very easily using your, 180 minus these two. And then we know C is 446 miles. So I'm going to let you figure this out using law of sines, laws of cosines, whichever one you want to use. Just pick the right one because there is a right one to use. And you will solve for everything. Okay? You will solve for A and B, the distance between the satellite and both facilities. All right, so good luck. Make sure you draw out your scenarios so you can see what's going on in the following questions. Have a good evening.